Hi guys, thanks for joining me. My name is Oliver Franzke and I'm the lead programmer of Broken Age and also most recently Day of the Tentacle Remastered. And today I want to give you a short history of the technology used to make point-and-click adventure games. So I'm going to be talking about, how these games were made all the way from, the early days of Maniac Mansion and Monkey Island up to a contemporary point-and-click adventure game like Broken Age. And hopefully I will be able to show you that these early days really revolutionized the games industry. And not just because of the story, the humor, and the game design, but also from a technological point of view. But before we're going to jump in, just a few words about myself. I started working in the games industry in the year 2000, and I started to work for a small German games company. Then I worked for Sony in London for a while before moving to California to work for LucasArts Entertainment. And eventually I joined Double Fine Productions, where I was working for the last couple of years. So here are a bunch of the games I worked on in my career, and I consider myself pretty lucky to be able to contribute to so many awesome games. And if you look closely, you'll notice there are a whole bunch of point-and-click adventure games actually in that list. And that is great because I really love this genre and I love playing these games. I love making these games. So I really consider myself very lucky in this regard. And so in the last 8 years or so, my role as a programmer really has looked a little bit like this. And even though I'm not going into old tombs and to steal or I guess recover treasures, I have been going into old code bases to kind of try to figure out how games were made, in the mid to late 80s, and like all the time in between, to then bring these kind of classic games back to contemporary hardware, so that people can enjoy it on their smartphones, their consoles, without needing to use some kind of emulator. So in a way, I like to sometimes say to people that my job title is kind of a code archaeologist. And of course that means I don't get a cool hat and a whip like Indy, but on the other hand I'm also not going to get chased by a gigantic stone ball. So today in this presentation, the next hour or so, I really want to focus on these 5 games. Because these are the games I personally worked on, and so I've gained some insight in how these were made and how these work. And just in case you're wondering when these games were originally released, you can see this here. So we're essentially spanning a time range of about 25 years. And a quarter of a century is a really long time in the games industry, because as you know, it's a very young industry, that's in many ways still finding its way. So for me, it was really awesome to be able to kind of look at how this genre has evolved over the years, and also, of course, how the technology has changed over these years. Now, of course, I wasn't directly involved in the original versions of Monkey Island, Day of the Tentacle, or Grim Fandango, but instead my contribution to these games were through the remastered or special edition versions that were released in the 2000s, as you can see here. Now, another way to look at these 5 games is by the technology used to make these games. And all the kind of original 2D point-and-click adventure games made by LucasArts were made with an engine called SCUMM. And I'm going to be talking about what SCUMM is and what made it so special in just a second, before also giving you some insight in how the special edition versions of these games were made. Then we're going to be looking at Grim Fandango for a little bit, and also how the remastered version was done, before eventually taking just a very brief look at Broken Age and the technology behind this game. But let's get started. Let's jump right in with SCUMM. Now, SCUMM is an abbreviation that stands for Script Creation Utility for Maniac Mansion. So, as the name suggests, this was a piece of technology that was developed for the classic point-and-click adventure game Maniac Mansion. Now, of course, Maniac Mansion is one of the earliest, and if not the first kind of big visual point-and-click adventure game that really kind of popularized this genre. And this game was written and designed by Ron Gilbert in the mid to late 80s, at Lucasfilm Games. So this was at a time where LucasArts didn't even exist yet. And as rumors has it, there was a little bit of a rivalry going on between Steven Spielberg and George Lucas. And when Steven Spielberg decided to venture into the interactive entertainment field, George felt that he had to follow suit. And so he set up his own gaming division under the Lucasfilm company. So, he hired then Ron Gilbert to, work on what would later become Maniac Mansion. And in this game, just in case you haven't played this, you're venturing into an old creepy mansion where you have to save one of your friends. Now, what is interesting about this genre of point-and-click adventure games is that you interact with the games essentially by forming sentences. So at the bottom of the screen, you can see there are various verbs like open, close, read, and so on. And the way you play this game is by essentially first clicking on one of the verbs, like for example, walk to, and then clicking on an object, like the fence. And then you have a sentence that's, walk to fence, and then the character that you have currently selected will perform this action. Now, a more complex example would be to open a locked door. You could say, for example, use key on door, and then the character would unlock this door. Now, SCUMM was really a huge success. Even though it was originally developed for Maniac Mansion, it was then used to make many, many other games. And here are all the 12 games made at LucasArts with the SCUMM engine. And as you can see, this era spans a time of about 10 years. And personally, I would consider all of these games really classic, cornerstone games. And, I played all these games. I love all of them. Even to this day, I come back every couple of years to replay one of these games. Now, I should mention that in the mid to late 80s, this was very, very uncommon. And so in a way, it was very uncommon that you would reuse, an engine for multiple games. Usually back then, when you made a game, you kind of wrote a very bespoke piece of technology for this very specific purpose of the game you were making. And then when you would move on to another game, you would essentially kind of throw away most of it and start from scratch. And so SCUMM really kind of revolutionized the games industry by saying, okay, why don't we just, have a piece of technology that we can then use for other games or similar games where we just kind of plug in different data. Of course, other companies at the time were doing something similar. id Software, for example, wrote idTech, and they were able to reuse that for multiple projects and, were very productive as well. But SCUMM and all the programmers at LucasArts were really kind of trailblazing at this time. Now, one interesting aspect is that SCUMM was actually used outside of LucasArts as well. Because when Ron Gilbert left LucasArts in 1994 to form his own company, Humongous Entertainment, he came to an agreement with LucasArts that he would be able to continue to use SCUMM as an engine for his projects that were mostly educational point-and-click adventure games for kids. And Humongous actually ended up making 40 or more or so games using SCUMM. So you could say, in total, SCUMM was used to make at least 50 games, which is pretty amazing, I gotta say, especially for the time when it was originally developed. Now, of course, the idea of a reusable engine is completely common now with Unity and Unreal and so on. So it almost seems silly that that people would have done it a different way. But that's how it was during the early days of the games industry. But what made SCUMM so special? And there are various reasons, and I'm going to highlight a few of the key aspects that made SCUMM such a successful piece of technology. And one of the key aspects, in fact, that the engine is named after, is the scripting interface. As I said, SCUMM is an abbreviation for Script Creation Utility for Maniac Mansion. And what that means is that the game designers were able to express and implement all the gameplay logic in a high-level domain-specific language. Or in other words, a scripting language. Now, this was completely revolutionary at its time because back then you would implement games most common in a more low-level language like C or assembler, which was mostly for performance reasons. But in SCUMM, they went a very different way. And the rumors has it the way this came to being is because when Ron Gilbert was first prototyping ideas for Maniac Mansion, he realized that he would not be able to make this game just writing assembly code. So he got together with two of his colleagues, Eric Wilmunder and Chip Morningstar, and these three came up with the idea of essentially an interpreted language where you would be able to write the kind of gameplay logic and all the puzzles and the conversations and all that stuff in a very high-level domain-specific language that would be very easy to write this kind of logic in, and that then this would be compiled into essentially just a list of bytes, or as we call it today, bytecode, that would then be interpreted and executed in an underlying kind of engine layer. And this engine layer is called SCUMM, or SCUMM Presentation Utility, TM. As a little side note here, the programmers back then really had a good sense of humor, because many of the tools associated with SCUMM have funny names. For example, there's a tool called Bile, and one that's called Flam, and so on. So again, I guess that proves you should probably not let your programmers decide what the program should be called, because they're going to be coming up with interesting names. Now, the interesting aspect about this engine layer, the SCUMM layer, is that if you wanted to port the game and bring it to a different platform, for example, from the C64 to a DOS platform, all you need to do is to convert and port this engine layer. Once SCUMM would run on a new platform, the existing game would just kind of work. And so this made it very easy to bring these games to other platforms, which again, was a bit of a new thing back then, because very often, you would kind of write the game for one specific platform, and then you would perhaps afterwards, if it was success, then hire somebody else to then take this code base and port it, to a different platform. And so portability is obviously, a very important aspect that made SCUMM so successful. And the other aspect is that since the gameplay logic was implemented in this high-level language, it meant that the game developers could be, would be very efficient implementing various ideas for gameplay ideas, and they could iterate very quickly on these ideas, and therefore kind of really polish the experience and come up with really cool stuff that otherwise would have taken a kind of a long time writing this with, let's say, C or assembler. Now, as far as I know, the SCUMM scripts for all of the LucasArts games were never officially released, which is why I'm glad that Ron Gilbert himself actually showed a little bit of script in his recent classic game postmortem about Maniac Mansion at GDC. Now, so if you find this talk interesting and you want to know more, then really I encourage you to check out this link at the bottom of the page here, because if you know Ron, he's a really, really funny guy. So in this very humorous talk, you will learn a lot about kind of the early days of LucasArts and how Maniac Mansion came into being. Now, excuse me, in this specific example here, we're going to be looking at the grandfather clock in the kind of main entrance hall in Maniac Mansion. So this specific script essentially kind of makes the pendulum swing from left to right. So as you can see here on the left side, first we give that script a name, we say it's called clock tick, and then we essentially have an infinite loop. So this do statement with the brackets means that the statements inside of these brackets will be repeated indefinitely. Now, what we're doing inside of this loop is essentially changing the clock state. So, for example, if the pendulum is at the right, then we'll set the pendulum to be on the left. Then we're updating the visual representation of the pendulum, as in we're setting a different sprite. And then we're also playing a sound along with this kind of visual change. And then we wait. And then we continue. So we change the pendulum from the left back to the right. We update the visual representation, play a sound, and so on. And so as you can see, it's very easy to express this kind of behavior in the script. And it's meant that the game designers could add these kind of ideas pretty easily. Even at a pretty late stage in a project, they could add these kind of ambient animation aspects, and they didn't need like an animator to go and to define some kind of custom animation. They could just do this programmatically, but in a very easy way. Let's look at a more complex example. So in this example, we're looking at a cutscene where the nurse Edna talks to Ed. Now, as a little side note here, SCUMM is also responsible for introducing the word cutscene into the games industry. And that is because in Maniac Mansion, a cutscene was a script that would literally cut away from your currently user-interacted environment to switch the camera to a different scene where a pre-scripted kind of scene would play out before then eventually cutting back to the player so you could continue playing. So depending on whether or not you like the word cutscene, I guess you can either thank or blame the SCUMM developers from these days. Now, in this specific script, what we're doing is we're first putting the nurse into the room on the right-hand side. Then we're saying, okay, well, we want to see the room, so we're putting the camera also in this room. And then we say, okay, nurse, now walk from the right-hand side of the room to the center. Then we're waiting for this to complete before then saying the line, what's your point at? And then waiting for, for this line to complete. Now, what strikes me, when I see this is that how easy it is to express this relatively complex behavior in just a simple linear fashion. And in fact, when I first saw SCUMM scripts when I worked on the Monkey Island Special Editions, I really realized pretty quickly that this was designed very similar to how you would write a stage play. If you ever seen a script for a stage play, it's usually kind of a linear sequence of things that should happen. Like, for example, an actor enters the stage, then walks to a certain place, and then says a line, and so on. And I don't think that's by coincidence. I think that's very much by design, and in fact I will come back later to this similarity in the talk. So as you can see, it's very easy to just kind of express this behavior just kind of in a few linear commands. And I want to kind of prove to you, how much more efficient this representation is than implementing this in a kind of more general purpose programming language that would have been used at the time. So let's look at just these three lines here, where we're waiting for the nurse to arrive in the center of the room. Then we're going to say the line, what's your point at? And then we're waiting for this line to complete. If we would imagine implementing just these three lines in a kind of a C-like language, then it might look like something like this. Now I should mention, this is a completely made-up example. This code on the right-hand side does not exist in an actual game somewhere. I just kind of want to show you how you could possibly implement a similar behavior in something like C. So even if you don't really program, you will realize pretty right away that this is a much more complex piece of code. There are way more lines. There's kind of a whole bunch of nesting going on and brackets and things like that. And as a programmer, that usually, added complexity usually means that, first of all, it's much harder to change. So if you wanted to kind of modify the behavior a little bit, let's say you wanted to, make the nurse walk to the door first, close the door, and then come back to the center, this would be very complicated to add this to the implementation on the right-hand side. Whereas in the SCUMM script, this would just be 2 or 3 extra commands in the script. And added complexity also means that it's much easier to add bugs to this code. And then also, because of that, it's much harder to find and fix these kind of bugs. So I'm really, when I first saw SCUMM script, I was really amazed by how efficient it is to implement these kind of specific games with this language. So I really you have to give these guys credit for coming up with this amazing innovation. Now, of course, these days scripting languages are very common. You wouldn't even think about writing implementing a game without some kind of high-level scripting language. But again, back then, SCUMM and other similar engines were the first ones to really establish this and to kind of therefore revolutionize the games industry, to make it possible for us today to use scripting languages everywhere. Now, if you find this kind of interesting, you would like to know more about the SCUMM language, you would have been out of luck just a few months ago. But just recently, Eric Wilmunder, the main programmer of the SCUMM engine, has recently started to release some of the documents that were written at this time when SCUMM was initially developed. So you can, for example, go to this link here on this slide and download the SCUMM manual that describes all the different commands and what they do. You can also download the SCUMM tutorial that was given to new programmers that joined LucasArts that kind of explains how you would make a game with this. And by the way, I really love the sub-tagline of the SCUMM tutorial: rising to the top of the software cesspool. I can only imagine it must have been a really, really fun time to work at LucasArts back in those days. Now, SCUMM, but the scripting is just one of the aspects that made SCUMM so special. Another killer feature that SCUMM added and is cooperative multitasking. What I mean by that is it essentially let you express various aspects of an environment that would happen at the same time in a very easy way. So for example, you could have the pirate spinning on the chandelier here. There could be a fire that's kind of animating, and there could be various other things, like for example Spiffy moving his head around and so on. But as a programmer, the way you would implement this would be like that. You would essentially just write independent kind of blocks of code that would execute in parallel as far as you would conceptually see that, without really needing to worry about the context and the room, and without needing to like manually add this behavior to kind of a list of actions that supposed to be performed in a frame and so on. So in a way, SCUMM kind of introduced the idea of like concurrent or parallel programming to the games industry. And I should say that in the mid to late 80s, this was completely mind-blowing, because at this point nobody had a computer with multiple CPUs, and the kind of the aspects and problems and challenges associated with with parallel programming were just being kind of discussed and analyzed by scientists. So you really have to give a lot of credit for Eric Wilmunder and the other SCUMM programmers for introducing this very, very powerful concept that let you do a lot of really awesome things at this time. And I'm still very much baffled by this. This is really amazing to have this. Okay, so now I want to switch gears a little bit, and I want to kind of show you how an environment in a SCUMM game is drawn, and like all the different elements that make a scene. Now, in SCUMM, an environment is called a room, which is of course because of Maniac Mansion, where the majority of the game you actually are playing inside of actual rooms. Of course, after Maniac Mansion it became a little bit of a misnamed data structure, because you would actually, a lot of the games would play outside, like in Monkey Island, for example. But at this point, the data structures were named, so that's what it is. Now, in our specific example here, we're going to be looking at the SCUMM bar from Monkey Island 1. Now, the way this environment is drawn is essentially in layers. So we would first, draw the background as a kind of image, as you can see here. Then there could be a layer of objects on top of it, and I'm going to be coming back what objects are in just a second. Then there could be another layer of kind of environment art or midground elements, and then another layer of objects on top of that. Now, of course, we also need kind of the kind of main characters and other supporting characters, and these are called actors that can also be in any of the layers. Now, even though I kind of show it to you here as kind of a list of images that is essentially drawn on top of each other, internally it's not actually represented like this. An environment is really just one single image, and in addition to color information, each pixel also contains information about which layer it is associated with. So here you can see this. Green is layer 0 or the background layer, and red is layer 1 or kind of the kind of foreground layer, so to speak. And of course, this was a much more efficient way to store this data, and so therefore that's how that was done. All right, well, let's come back to objects. I already mentioned these earlier, and objects had multiple purposes. So first of all, like I mentioned earlier already with the grandfather clock, objects were a way to kind of add ambient animation or a little bit of movement to these scenes, by essentially making it possible for a gameplay programmer to implement a kind of very simple animation by just kind of iterating or looping through various sprites. Now, the secondary and perhaps more important aspect of objects is that they, were essentially things that the player could interact with. So each object, has a hitbox associated with it, and if you click on it, then the game designer could, implement a custom response to that interaction. So, for example, if you were to say, talk to pirate, then as a game designer, you could then implement kind of a conversation between Guybrush and the pirate. Or you could say, if the player wants to push the pirate, then you could add like a custom response because the pirate probably doesn't like that. Or, additionally, if you want to combine various things, for example, you want to use the grog on the pirate, for example, then, you could, again, implement some kind of response to that. Now, of course, once you need a little bit more advanced or complex animation state, you will have to use actors. And under the hood, actors are really just kind of a collection of different values. So in the engine, there's an array of actors that's persistent, and each actor has, first of all, a position in a room, a scale. It also stores information about which room this actor is located in, and also which costume this actor is wearing, in which direction it's facing, and so on. Now, the interesting aspect here is that is the room, because actors are, as I mentioned earlier, are persistent, which means that actors that are that are located in rooms other than the one that the player is currently in can still do stuff. So you could have a script still executing on an actor in another room. And of course, this opens interesting opportunities for game design. For example, in Monkey Island 2 and Day of the Tentacle, this was used, for example, for chase scenes where somebody would chase you, and you have to stay ahead of that other player. Now, of course, we want to be able to see the actors, and this is done through costumes. So, like I mentioned earlier, the similarities to stage plays is really everywhere. Just because these data structures are named like that, actors and costumes. Because just in real life, when an actor performs in a play, he first puts on a costume before he enters the stage. And during a play, the actor can wear various costumes, and that's the same here. So you can see here's a list of all the sprites for Guybrush's main costume in Monkey Island 1. So under the hood, a costume is really just kind of a collection of various sprites that could be displayed. And logically, this is structured in a list of animations. So each costume could have one or more animations associated with it. And then each animation could have one or more chores. And I'm going to be talking about what a chore is in just 1 second. And then each chore can have one or more limbs. And limbs is where, is essentially the fundamental unit a unit of animation that contains the actual sprites. Now, I should mention that limbs are really used as a very flexible sense of the word, because characters in the SCUMM games are not made out of individual limbs. So like they're not assembled by adding arms and legs and whatnot, and then combining all of these and drawing them as separate sprites. But instead, limbs really represent kind of logical units of animation. So in this specific example that you can see here, it's Guybrush's talk animation. So one of the limbs is actually Guybrush's entire body because it's static. So during the animation, the body is not doing anything, it's just kind of staying fixed. So therefore we just need to display one sprite for it. Now, on the other hand, the head is changing over time because Guybrush is kind of nodding his head and opening his mouth and so on. So the second limb is the head. And for that, we're just essentially iterating or cycling through the list of sprites associated with this animation. Now, I mentioned chores, and chores are essentially an instance of a specific animation. So, for example, for a walk animation, it of course matters which direction the character is facing when it comes to selecting the sprites that should be displayed. So for the walk animation, there's a chore for the front, so Guybrush is walking towards the camera, Guybrush is walking to the right, and Guybrush is walking away from the camera. And these have different lists of sprites that need to be displayed. And the nice thing here is that as a game designer, you could just say in script, hey, play the animation walk on that actor. And then the engine would figure out, based on the context, or in this case the direction, which specific list of sprites should actually be displayed. And again, you can really feel that the purpose of, or the design principles of the SCUMM language are to make it as easy as possible for the game designers to express this kind of behavior. Now, talking about walking, there's still one piece of information missing, and that's the walk boxes, because we have to tell the game somehow, where you can walk with Guybrush in the SCUMM bar. And this is done through walk boxes. Now, walk boxes are essentially just a list of trapezoids that are chained together, and each one of them contains, first of all, information about which layer the actor is supposed to be in when he's located in that walk box. So here in this specific example, you can see the green walk boxes are the ones where Guybrush would be in layer 0, and the red ones are the walk boxes where Guybrush would be drawn in layer 1. And so this makes it possible for the game to essentially make Guybrush walk around, for example, the table with the important looking pirates on the right hand side. So when he wants to walk behind the table, then we would use the green walk box there, which means he would be drawn in the background. And if we walk in front of the table, then we would use the red layer, the red walk boxes, and he would be drawn after the table and after the important looking pirates. And other values could be also associated with walk boxes. So for example, scale. You could, for example, define a scale value for the top of a walk box and a different scale value for the bottom of the walk box, which means that you could create like a fake perspective effect, because Guybrush could be becoming larger while walking towards the camera. And later games like Day of the Tentacle will then also use these walk box values to, for example, encode kind of lighting information. So if Bernard, for example, walks into a shadow, his character darkens, and this also will be represented through attached attributes to these walk boxes. Now, you can probably tell that I'm a big fan of Monkey Island, since I'm kind of gushing about it. And that's true. In fact, I would say that's probably one of my most favorite games of all time, which is why I was very excited when I decided to join LucasArts. And I remember telling my friends jokingly that my one goal for going to California is to make LucasArts to make adventures again. And of course, back then that was kind of really more of a joke, because LucasArts was focusing on kind of AAA big projects like in the Star Wars and Indiana Jones universe, and they really did not want to touch these kind of old classic point-and-click adventure games. So here is a photo of the team I was hired on, and as you can see, it's probably pretty easy for you to spot the programmers. I'm there on the left side with the red jacket, and all the programmers stand around a little bit awkward while the rest of the team seems to have a really good time. I guess some stereotypes really are kind of true. But as life plays, just a few months after I joined LucasArts, the management was completely replaced. And as it often is in these cases, this comes with project cancellations and layoffs and so on. So we essentially all of a sudden had no project anymore that we were supposed to work on. And that was pretty frustrating for us, because most of the team was just hired fairly recently, and we were all pretty excited, and we came to LucasArts to do cool stuff. And at the same time, being in the Bay Area, we also were in the epicenter of the smartphone revolution. Of course, Apple brought the iPhone to the masses, and with that we saw people come into the office with these incredible small computers with really nice touchscreens. And we realized pretty quickly that smartphones and tablets really are a fantastic platform to play these kind of old classic point-and-click adventure games on. So in this kind of time where management was trying to figure out what they're going to do with the company, we decided to start our own little rogue project. And we started to digging through the archives to see if we could find the source code for the original Monkey Island. And in fact we did, and we made it to compile and run on an iPhone, and that was pretty awesome, because we could now actually play this game on this neat little mobile device. But we realized pretty quickly that while the game is fantastic in terms of game design and dialogue, it really kind of visually it looked outdated at this point. And I think for me personally, that's very often with nostalgia, it's kind of like that, where you kind of come back to an old game you really loved as a kid, only then to realize that you have very different imagination of the game in your head. The reality is often kind of different. So we decided, hey, maybe we can add a bit of kind of improved art on top of the original game, and this is what eventually would become the special edition. And one thing we wanted to do is we wanted to make sure that the environments kind of look a little bit more lively. So we started adding a lot of kind of ambient animation, like the water here or the clouds in the background. And I think it really helped to make these environments feel a little bit more alive and like a real place. And the special editions really worked through an engine that we jokingly called the Remonkeyed engine. And one of the core decisions we made pretty early on that was really important is that we loved the original game so much that we wanted to keep it completely unchanged. So we ran the original game in a sandbox, meaning that we ran the original code with the original SCUMM gameplay scripts and the original data. So as far as the game was concerned, or as far as Monkey Island was concerned, it was still running on a DOS computer in 1990. And on every frame for the remastered version or special edition version, we would essentially look at the state that the original game is in, and then reinterpret the state with improved art or sounds and so on. So for example, this specific instance here, we would look at, okay, which environment are we in? Well, it's the prison. Okay, so we would draw the kind of redrawn prison environment. Then we would look at, okay, which actors are in this scene. Well, there's Guybrush, for example. Okay, right, which costume is Guybrush wearing? All right, it's this one. Which sprites are currently being displayed in the original game? And then we would pick the remastered versions of these sprites and show them instead. Now, this architecture has the huge benefit that it means that the original game is still completely, running completely untouched and actually producing an image. Which means, of course, that you can then fade between these two versions, the remastered version and the classic game. And this was a feature we kind of were brainstorming about with the programming team one day. And I thought, this is a really cool idea. And I, just hacked it into the engine in about an hour or so. And it was a really cool moment, like seeing this working for the first time. And then, we started showing the version that we had at this point with the fade to the new management. And, they really liked what they saw. And eventually, and thankfully, they gave us the go-ahead to make this a real project and to, complete it and then get it out on the various platforms you can see at the bottom of the screen here. So here's a specific example from Monkey Island 2, how that fade looks like. So you can see, we generally tried to capture the essence of these scenes and just make them look more contemporary. And a lot of the water here in this case, we remastered using particles and shader effects, which was necessary because the original water animation is using an 8-bit animation technique that's called palette cycling. Meaning that we kind of, for each palette entry, we're iterating through various colors. And that's actually kind of surprisingly hard to re-implement on current graphics cards. Now, here's another example. As you can see, the gameplay is exactly the same, but we made the floor a bit more shiny, and we added some particles, like for the light shafts, so the window and stuff like that. So we generally kind of try to envision, like, how would the game designers, and the artists, made this game look like if they would have had all the hardware that we have. All right, well, let's move ahead and let's go to 1998 and to Grim Fandango. Now, Grim Fandango was Tim Schafer's last game at LucasArts, and Grim Fandango is also very much an adventure game. In this game you play as Manny Calavera, who's a travel agent in the Mexican afterworld, who has to kind of solve various puzzles and solve various mysteries. Now, unlike the kind of 2D kind of point-and-click adventure games like Monkey Island, Grim Fandango really kind of moved forward and visually, because the game is using a 3D rendered character on top of a pre-rendered 2D environment that then gets integrated. Now, of course, this was a kind of a popular idea at the time. Resident Evil is another perfect example that did something similar. But at its core, Grim Fandango is still, an adventure game where you combine inventory items and talk to people, and you have to navigate spaces to move forward with the story. Now, what is interesting though is that at LucasArts, they did not use SCUMM to make Grim Fandango, and that is because Brad Morgievsky, who's the lead programmer of Grim Fandango, initially, analyzed how much work it would be to make SCUMM a 3D engine. And he realized that it would actually be a lot of work. In fact, so much work that it actually doesn't make sense to do this conversion, but instead to write a new engine from scratch for this specific purpose. Of course, this meant he kind of had to decide which elements from the original SCUMM engine they wanted to add to this new engine. And Tim and other game designers said, like, okay, well, one thing we definitely need is the scripting language. We want to continue to implement the gameplay logic in a high-level language. So Grim Fandango, just like the old SCUMM games, makes this possible. So again, you implement all of the kind of gameplay-specific things in a scripting language. But now, instead of designing and implementing his own custom scripting language, Brett decided to use an open source project called Lua. Now, these days, Lua is a very common choice for scripting engines in games, if not the most common choice. But back then, as far as I know, Grim Fandango was the first major release that used Lua. So again, this kind of step forward also meant a little bit kind of innovating in the games industry, and bringing something new to the table that would then eventually become the standard. But Lua aside, the engine for Grim Fandango was much more contemporary and modern in many other ways, because Brett decided, instead of implementing a lot of things from scratch on his own, to reuse existing code from other projects. So, for example, the video playback system in Grim Fandango actually used insane. It was called insane. It's also insane, I guess, from the code perspective, but used the insane video playback system originally written for Rebel Assault. And the 3D rasterizer was used. The 3D rasterizer from Dark Forces 2 was used here to draw Manny and all the other kind of characters. So this kind of modular approach to implementing a game engine is definitely kind of a big step forward, and made this engine much more contemporary. So now again, I want to give you kind of an impression of how an environment in Grim Fandango was kind of drawn and the various elements. Now, one interesting aspect is that since the engine was written from scratch, this meant you could also rename all the data structures. And one of the changes compared to SCUMM is that the environment is now called a set, which of course makes way more sense than a room, because again, also in Fandango you spend a lot of time outside of buildings. And the set has kind of a secondary meaning because in an environment you can actually see it from various different camera angles that had been generated. So while you're walking around in this environment, the game will pick the camera angle that fits the current view best, and then shows you the game through this camera angle. So let's look at kind of how the environment is drawn. So first of all, let's look at the backgrounds. And the backgrounds were modeled and rendered in a kind of high-profile 3D modeling package called Softimage. And so, this was kind of a production renderer, and it would, produce really nice-looking environments. And each pixel would not only contain color information, but they decided to also produce a depth buffer for each pixel that you can see on the right-hand side. Now, a depth buffer essentially contains information for each pixel, how far this pixel is away from a camera. And this will become in handy later on. Now, as a little side note here, you can see that this game was made in the 90s, because if you look at the coordinate axis here on the left-hand side, you'll notice that the z-axis is pointing up, which for me as a graphics programmer really hurts, because the y-axis is the one that's supposed to point up. But anyway, it is what it is. Now, of course, environments in Grim Fandango also have objects. And again, like in SCUMM, objects are they're mostly to have something for the player to interact with. So an object, has a hitbox, and again, you can implement various custom responses to, different interactions. And visually, objects could be represented either through a fixed sprite, so just an image, or it could be an animated sprite using the video playback system, or it could be a 3D object. And the 3D object would be then rasterized or rendered using the Dark Forces 2 software renderer. And for each pixel, the renderer would check out, okay, well, is the pixel that we're trying to draw right now closer or further away than the background? And in order to make the decision, it would use the depth buffer that was, produced by Softimage to see, whether or not the pixel should be visible or if it's hidden behind something in the background. And this is how all the kind of real-time 3D objects were integrated with the environment. Now, of course, again, just like in SCUMM games, the most important aspect about the environment are the actors and the costumes they are wearing. Now here, actors again are really just kind of a collection of different values like position, scale, and so on. And costumes are the things that actually make the actor appear on screen. Now, unlike SCUMM, costumes are actually 3D models. And back then, they used rigid mesh animation, and what I mean by that is that the body was essentially made out of individual kind of geometric primitives that could be rotated and moved. So in this specific case of Manny, for example, the upper body would be one mesh, and then the upper arm would be one mesh, and the lower arm would be a separate mesh, and then the hand would be a mesh, and the various joints would be meshes. And if you want to animate this, you would, for example, if you want to make Manny wave, then you would rotate the upper arm that was pivoted at the shoulder a little bit, and you could also rotate, in addition to that, the lower arm at the elbow where the lower arm was pivoted, and then this kind of entire hierarchy would move. So in order to animate those characters, all you will need to do is essentially store these kind of rotational values over time. And that's how that was implemented. Now, I eventually left LucasArts, as I mentioned earlier, to join Double Fine. And unfortunately, even after I left, LucasArts really did not become a very stable place to work. Various managements were replaced and re-replaced and so on, until eventually in 2013 the company was closed, which was after George Lucas had decided to sell LucasArts and his other IP to Disney. Now, of course, for us at Double Fine, this meant that we could, actually give the same treatment to Grimm that we have previously given to Monkey Island, and to kind of remaster this fantastic game, and make it available for players to experience on contemporary hardware like mobile devices and consoles and so on. And this is what eventually, became the remastered version of Grim Fandango. Now, one thing that we noticed when we started to look at the original game is that the environments actually still looked pretty good. Since they were, rendered in Softimage, they really, had looked pretty good, and they had a lot of, lighting baked in, and generally kind of still seemed, pretty contemporary. On the other hand, what did not look too good were the characters. Because they were low resolution, the textures were kind of pixelated and blurry, the lighting didn't really work, and the shadows were really blocky, and all of that made the characters kind of feel out of place in this environment. So when we decided what we wanted to focus our attention on when remastering the Fandango, lighting was really on top of the list. So on the right hand side you can see the same scene in the remastered version. And you can see, the textures are much more crisp, and the lighting, looks much more realistic, and the shadows look much better. And all of that really, I think, helps to integrate Manny into the scene, so he really looks like he belongs in this environment. Here's another example. Again, I think you can see, the polygons are, due to the higher resolution, look much sharper. The textures are much crisper, and the shadow correctly projects onto the ground and the wall and background. Now, how did this work? Well, we used a very similar approach than we had previously used for Monkey Island, and of course that's not a surprise because we really felt that remastering Monkey Island worked pretty well. So just like before, one of the key decisions we made early on is to keep the original game completely unchanged. So again, we ran the original code with the original gameplay scripts and the original data in a sandbox. So as far as Grim Fandango was concerned, it was still being ran on a DOS computer in 1998. And then just like before with the Monkey Island games, every frame we would look at the internal state that the original game is in and then reinterpret this. Now here it's a little bit different because the characters were actually already in the original version made out of 3D meshes. We actually ended up using the original meshes also in the remastered version. Because they were created with the art style in mind, and the actual geometry really kind of held up even in the remastered version. What we needed to replace though were the textures. So whenever a character was drawn and would request a certain texture to be used to draw a piece of a mesh, we would then instead kind of reroute it and use the remastered version of that texture. And this also allowed us to integrate other changes like the lighting I mentioned earlier, sounds, and so on. And of course, this architecture, just like before, meant that we could, again, blend seamlessly between the original version and the remastered version, which was a feature that we really liked and we wanted to make sure to also add it to the remastered version of Grim. Now here's a specific example, you can see, a direct comparison between the original game on the left-hand side and the remastered version on the right-hand side. And you can see, I think, first of all, you will notice that, Manny really looks like he belongs to this environment. He integrates much more nicely. You can see all the shadows are kind of projecting correctly onto the table and the walls. And the way we remastered the lighting is actually by kind of looking at how the shadows looked like in the original backgrounds. And then based on these kind of shadow angles, we would then place light sources that would emulate this behavior even on the characters. Now here's another example from the first scene in the game, and one thing that was interesting, the original game, due to the performance reason, couldn't calculate the lighting correctly. So even though Manny is currently standing in the shadow, he's completely brightly lit, which means that he really looks like he's kind of just glued on top of that image. And in the remastered version, we were able to fix this and actually make him appear dark like he's supposed to. And more than that, we actually were able to, as you can see, to add this kind of film noir blind shadows to the environment. And overall, I think this really helped to make this appear like a real place. Now, in order to be able to do the remastering specific for the lighting, we needed to be able to kind of get the original environments as 3D models. Now, unfortunately, we couldn't find the models used to, render these environments in the archives. So instead, we decided to essentially generate those by back projecting the depth buffer and the color information from the different camera angles into 3D. So you can see that here as an example. So you can see all the various different camera angles that are used in the office in the first scene in the game, and how they are being placed in the world. And you can definitely make out various shapes and where different aspects in this environment are. And it looks a little bit like one of those Kinect depth visualizations, and I think it's pretty cool. And then we use this essentially to allow artists to place light sources and various other objects into the scene for the remastered version of the game. So on the right hand side you can see all these wireframe objects. These are all light sources that were added to this office scene. Now the highlighted ones, the white one and the green ones, are the kind of directional light sources that kind of make the sunlight kind of coming through the windows. And then you might notice there are some these gray boxes there also on the right hand side. And these are shadow primitives that we allowed the artists to put into the scene that would then affect the shadow that's being projected onto the characters. So this way, this is how we essentially make the blind shadows work in this environment. And each room in Grim Fandango, the remastered version, really got this kind of treatment. Now you notice there are some other kind of gray boxes in the center of the room there, and these have various purposes. For example, we needed to kind of hack and override part of the original depth buffer. Unfortunately, I don't really have time to talk about it in this presentation, but hopefully at a later time I can come back to this because it's actually kind of an interesting topic. But let's move forward to 2013, and Broken Age. Now, at this time at Double Fine, we kind of really thought like, hey, wouldn't it be awesome if we, could make a contemporary adventure game, point-and-click adventure game, like a game that really feels like the classic point-and-click adventure games like, Monkey Island, but that looks just kind of more modern and uses kind of the hardware that we have available now. To just kind of bring back this classic feeling that came with these kind of games, and the humor and kind of the cerebral aspects of like solving puzzles and so on. Now, back then it was really hard to find a publisher to finance this kind of project, because publisher thought this would never sell, and therefore we're not gonna take the risk and give you money for this. And at the time we decided to use a crowdfunding platform that was back then not really known for big game projects, and that was called Kickstarter. Of course, these days Kickstarter is the de facto place to raising money for crowdsourced or crowdfunded game projects. And we really didn't know how this would turn out, and we were kind of amazed by the success that came with this project. And people and fans really loved the idea of bringing back this kind of game, and they said like we're gonna help you finance this. So we were completely humbled and amazed by this success, and it let us make Broken Age. And in this game you play as the girl Vela or the boy Shay, or actually and the boy Shay, who have to overcome various challenges in their respective story arcs. And it's a coming of age story, and I'm not going to give away too much about it, just in case you haven't played it. And it was really an awesome project to work on, and I really, really for me personally, it was like a dream come true to be able to work on a new adventure game with Tim Schafer. So a great time. And from a technology point of view, we decided obviously to be inspired by the original adventure games, like Monkey Island and Grim Fandango. So just like before, we of course decided that the actual gameplay logic should be implemented in a high-level program language, to make it as easy as possible to kind of implement these puzzles and dialogues and so on. And just like with Grim, we decided to use Lua. At this point, Lua was pretty much the de facto standard for scripting languages in the games industry. But now, obviously, since it's been years since Grim Fandango came out, we used the latest version, which was Lua 5.1. And also, for the first time, we actually decided to use an open source engine as the basis for this project. So we used a piece of technology called Moai that was originally designed and implemented by Zipline Games in Seattle. And on top of this engine, we added various other aspects or extensions, for example, for particles and lighting and so on, that helped us make this game. Now, an important aspect of Broken Age was to make this game available on as many platforms as possible right from the beginning. And so a big part of my role was to make sure that that Broken Age will run on everything we want to support. So here's a photo from my desk about, I would say halfway through Act 1. You can see the game is running on, a Mac and a PC. There's like various phones and tablets. And if I enable the platform overlay, you can see, we have like Android and iOS devices. And the other, even other platforms that we support are not even on this photo. And this was a really interesting challenge, and I enjoyed working on this very much. Now, since I showed some script earlier for Maniac Mansion, I figured I would give you kind of an impression how kind of a contemporary scripting language looks like. Now, the specifics here don't really matter, but essentially the script is responsible for what happens when you click on this kind of signpost in the center of the Cloud Colony, which is one of the early areas in Vela's story arc. And what we're doing here is we're essentially looking at the game state to see if we have already previously visited this area. And then based on that, we play a different dialogue set. And so you can see, it's again, pretty straightforward implementing that, although Lua is a more general purpose programming language, so it's a bit more complex than perhaps compared to SCUMM. But on the other hand, it also allowed us to do a lot of more interesting things and to kind of add a lot of aspects to the game that would have been hard to do with the original SCUMM engine. Now, just like before, I want to kind of give you a breakdown of kind of how these environments are drawn and what makes an environment in Broken Age. And for the art style, we decided that we wanted to bring the worlds kind of envisioned by Nathan Bagel Stapley to life, and make them to be the environments for this game. And so you can see, we are spanning, various aspects from sci-fi to like fantasy, and these beautiful environments often convey like a sense of depth and of size. And the way we did that is by actually modeling these scenes in 3D. So if you look at the clouds in the background, they kind of move relative to the foreground, which is called parallaxing. Now this is done by essentially creating the world in layers. And each layer can have various aspects associated with it. So there could be, as you can see, an image in the background. Then at various aspects, the distance to the camera, there can be other images, sprites, or characters like these birds or particles and all that stuff. So you can see, there's quite a lot of complexity that goes into one of these scenes that in order to make this such a kind of beautiful and grand environment. Now here's a screenshot from 2HB, which is the tool, the game creation tool we created for Broken Age. Now Broken Age, unlike SCUMM and Grimm, doesn't really have a notion of a specific object, but instead we did a lot of work with volumes and entities, which is kind of a much more contemporary way of structuring games. Now the details here don't really matter, but as you can see, there's a lot of complexity that goes into one of these scenes in order to kind of make this scene appear. It might be surprising to you, how much stuff there is in order to make this environment work. Now, at one way, which I think we really innovated the genre of point-and-click adventure games, is how the characters are made in Broken Age. Now, early on, we kind of discussed how we should approach the characters, and we decided that hand-drawn characters like they were done back in Monkey Island would not be a good choice for us. And there are various reasons for that. They're very inflexible. It takes a long time to create them, and then if you want to make changes to them, it's kind of difficult. But also, since we wanted to show the characters at various distances and level of detail, we felt that using a kind of fixed sprites would not be a good choice there, and also they would require a lot of data. We have like hundreds of thousands of animation frames in Broken Age, and to create these with hand-drawn sprites would have not been really possible. So instead we decided to create something that we call a hybrid rig. And what we're doing here is the characters are essentially modeled as polygonal characters in Maya, and then they get a skeleton rig associated with, just like you would do for, let's say, a contemporary 3D game, which allows the animators to animate and move different parts of the body, and therefore make them appear alive. But in addition to kind of making it possible for animators to rotate various parts of the body, we also allow them to show and hide different parts of the body. And this essentially makes it possible for them to add flipbook elements to a character when they need it. And by flipbook I mean, hand-drawn aspects of the body that you want to kind of combine with these polygonal meshes. And this essentially allowed us to combine both the benefits of both this kind of the 3D rig characters with the old school kind of hand-drawn characters. So we kind of got both of best worlds. And this was really important because for us, one of the main aspects that we wanted to achieve is that that the player would be able to really see the kind of emotional state that the characters are in. So, if Vala is happy or sad, or she's talking to someone and is kind of angry, you should really be able to see this to kind of really get a sense of that these characters are there, and they're going through a storyline, and they're reacting to the various aspects that they encounter in the world in different ways. So here's a specific example from Shay's side of the story. And when I enable the joint overlay right now, you can see that this is kind of a skeleton animation system where the joints kind of rotate and whatnot. But then also we kind of can combine it with the flipbook animations that you can see for the hair here. And this really allowed us to make this really hilarious animations and make these characters feel so alive. Now, one other aspect that we had previously learned is that we wanted to really make sure that the characters really feel like they're part of these environments. And this very often means, to make sure that the lighting really works. So we spent a lot of time working on the lighting technology. So you can see here when Shay steps out the teleporter, the lighting is changing on him, and then he's kind of walking over into the shadow area, he kind of darkens, and then he walks into this bright area and he kind of brightens up again. And you can even see from which direction the lighting is kind of illuminating him from. And this in combination with the directional shadows that you can see right now, and like things like the reflections that you could see there on the particles and stuff like that, really kind of helped, I think, to make sure that these characters kind of fit into these environments, and make the whole game kind of feel like a real place you want to explore. Now, there's so much more I could talk about. I haven't really touched on like the audio system I'm used that was designed for the original SCUMM games that kind of really revolutionized the way audio is done in games. And for all of these games I could probably talk for hours and talk about various aspects. But I've already kind of taken up a lot of your time. So I will kind of stop here, and I hope you enjoyed this presentation and you learned something new, and maybe you got inspired to work on your own adventure game. And if you have any questions about the stuff I touched on today or other aspects, feel free to either contact me on Twitter. You can see my Twitter handle down here on the right hand side, or you can send me an email, and I will try to get back to you. Now I'm going to end on this slide. Here's some other links you might want to check out if you are interested in this and you found what I talked about kind of interesting. I encourage you to check out those links. And with that, I again want to say thank you for watching this presentation, and I hope to talk to you soon. All right, bye guys.